Hi guys, so today we are on lesson 9.6, problem solving. We are problem solving by finding the rule that is being used in the problem. So, unlock the problem, page 411. On an archaeological dig, Gabriel separates his dig site into sections with areas of 15 square feet each. There are 3 archaeological members digging in each section. What is the area of the dig site if 21 members are digging at each time? So our question, what do I need to find? I need to find what do I need to find? What is the, so we're looking at our question, okay? We always start with our question. I need to find the area of the dig site. So what is the area of the dig site if 21 members are digging at one time? I need to find the area of the dig site if 21 are digging. That's what I need to find. Next one. What information do I use? I can use the area of each section, which is 15 square feet. That there are how many members in each section? 3 members in each section. And that there are 21 members digging. So that's the information that we have. 15 square feet, 3 members in each section. How will I use this information? I will use the information to search for patterns to solve a pattern problem. I guess they want pattern. To solve a pattern problem. I don't know. Then look down at solve the problem. So they already came up with the rules. We have 3 and 15. And we know that this goes plus 3, this goes plus 15. Now we need to figure out what did we do to the 1 to get to the 3. 1 times what is 3? 1 times 3 is 3. 3 times what is 15? 3 times 5 is 15. So those are our rules. So if I go out to where they stopped at 7 to 21, and then it would be 21, because that was 7 times 3 is 21. 21 times 5 is what? Let's figure it out. What's 21 times 5? (21 times 5). 1 times 5 is 5. 5 times 2 is 10. So 105. Okay. So possible rules off to the side, the dots that they have off to the side. So let's just fill in the information for them. First dot. Multiply the number of sections by 3 to find the number of members. So see, times 3, multiply by 3. Multiply the number of members by 5 to find the total area. Here's 5, here's 5, not a problem. So the area for the dig site of 21 members digging is 105 square feet. Okay? So I wrote down what the first one was, and I wrote down what the last one was. I didn't write down all of the ones in the middle, because honestly, we don't need all the ones in the middle. Not for these kinds of problems, because if we were asking, is there a pattern, we would need ones in the middle. But we know there's a pattern. It's not a question of if there's a pattern. So all I need to look at is the very first set of information, and I can figure out what's going on with the entire thing. I don't need to know anything except for this first set, and I can tell you everything that's happening in the entire pattern. Okay? Because we're told it's a pattern. There is no question here. This is definitely a pattern. Try another problem. Casey is making a design with triangles and beads for a costume. In his design, each pattern unit adds 3 triangles and 18 beads. Casey uses 72 triangles in his design. How many beads does Casey use? Use a graphic organizer to solve the problem. Okay. So, you remember, I like to do it question, information, operation. So, what is the question that we're solving? What information are we given? And what operation are we going to use? That's add, subtract, multiply, or divide. Okay? That's how I like to make these charts up. So our question, what do we need to find? How many beads does Casey use? So I'm going to put down are used. You can write the question down verbatim. That means exactly the way that it says. You can write down how many beads does Casey use. I'm simplifying it a little bit. Information. We know there are each 3 triangles and 18 beads. Okay, and then design 72 triangles. Okay, so each of them has 3 triangles and 18 beads. The design has 72 triangles. The operation we're going to use is a table. We're going to make a table. If you want the actual operation, it's multiplication and division, finding the pattern. So you could write down, find the pattern, find the rule, find the table, however you want to put it. So our table ends up looking like this. 1 times 3, and then 18. So if we have one set, 1 times what gives us 3? 1 times 3 gives us 3. 3 times what gives us 18? 3 times 6 gives us 18. All right? So using this and only this, I can now tell you what this is. I am told, because this is the triangle. Okay, so this is, let me write this in. This is sets, triangles, and beads. Okay, so sets, triangles, beads. This is a kind of ugly looking table, isn't it? If you just write sets, triangles, beads in front of it, and then you have one set, 3 triangles, 18 beads, you should be fine. All right, so in this case, our design has 72 triangles, which means the 72 goes in the same line as the 3. I do not know how many sets I have, and I do not know how many beads I have. But our question doesn't ask about how many sets I have. It only asks how many beads do I have, which means all I need to do is go down to beads, and that says it is times 6. So 72 times 6. 2 times 6 is 12. 7 times 6 is 42 plus 1, 43. So 432. Which means Casey uses 432 beads. What rule, at the very bottom, what rule could you use to find an unknown number of beads if you know the related number of triangles? Multiply the triangles by 6. And that's our rule. Multiply triangles by 6. That's all. All right, pause if you need to. I am moving on to the share and show on page 413. Number 1, Max builds rail fences. For one style of fence, each section uses 3 vertical fence posts and 6 horizontal rails. How many rails does he need for a fence that has 27 posts? First, think about what the problem is asking and what you know. As each section of fence is added, how does the number of posts and the number of rails change? Next, make a table and look for a pattern. Use what you know about 1, 2, and 3 sections. Write a rule for the number of posts and rails needed for 9 sections of the fence. Okay, so one section. Sorry, I need to actually label these things, otherwise we're going to get totally lost. Section, post, rails. So for one section, we have 3 posts and 6 rails. What did I do to the 1 to make it a 3? 1 times what? 3. What did I do to the 3 to make it a 6? 3 times what? 2. Okay, so that's our rule. Sitting here, possible rules. Well, okay, so rule for posts. Is multiply the sections by 3. Rule for rails. Multiply the posts by 2. Okay? So we end up with use that rule to solve the problem. Okay. So section 9. 9 times 3 is 27. And then 27 times 2, 27 times 2, 7 times 2 is 14, 2 times 2 is 4, plus 1, 5, 54. So we fill in the blank with a 54. So 9 over 20, the ninth section has 27 posts and 54 rails. Number 2, what if another style of rail fencing has 6 rails between each pair of posts? How many rails are needed for 27 posts? So this is number 2. We have I keep going on with okay, so sections, posts, rails. I keep forgetting to label the things. So section 1 has 3 posts and 12 rails. Okay. What did I do to the 1 to make it a 3? I multiplied by 3. What did I do to the 3 to make it a 12? I multiplied by 4. Now I can go over here to skip to whatever I please. So I'm going up to the 9th section. 9 times 3 is 27. 27 times 4 is 7 times 4 is 28. 2 times 4 is 8 plus 2, 10. So 108. So I would end up with 108 rails, and my possible rule is multiply posts by 4. Okay? Is this making sense to you? All that you need to do is figure out what they did to any of the parts, and you can then make the rule for the entire thing. So pick the one that you like the best. I know I've always been picking the first one that comes up. That's because I tend to find the first one that comes up the easiest one to work with because it has smallest numbers. But I could have gone to the 3, 9, 36 one. I'm looking at problem 2, and part of it says 3, 9, 36, and asked, well, what did they do to the 3 to make it a 9? They multiplied by 3, which is the same as there. See? What did they do to the 9 to make it a 36? They multiplied by 4, which is the same as right there. So you see, I ended up with the same answer. It's just, I think these numbers are easier to work with than these numbers, and that's why I've always been choosing the one that starts with the 1 at the top instead of going to the last one that shows up. All right. You should do okay. Just ask yourself, well, what did they do to each of those? And then continue doing the same thing to all of the other ones. All right. Talk to you guys later. Bye.